Today we are going to learn about the metric system and how to convert between units in the metric system. This is important because we use metric measurements in science. We also need to understand how the measurements compare to one another. First, you're going to take a minute, write down in the boxes at the top of your paper 2 things you already know about the metric system. Pause the video and do that now. When you're done, chat with a neighbor about what you wrote down, and then talk about if you think that the metric system is easier or more difficult than the English or our system. Hopefully you had a good conversation with your neighbor, and we're going to go on to the next slide. In the boxes on your page, you're going to be drawing what is in these pictures. So you're going to take a look at each bag of sugar. On the left, we have a Ziploc of sugar that contains 1 kilogram of regular table sugar. In the middle, we have a picture showing 1 gram of sugar. And on the right, we have a picture showing a milligram of sugar. The one on the right, I know it's very hard to see, but there are tiny particles of sugar in there. It's not very much. Discuss with a neighbor what you see, how they compare, and draw your picture in the boxes. You can see that all of these pictures all of these amounts are associated with the gram, but they represent very different amounts. The gram is what we call a base unit. Take a minute and talk to your neighbor. Talk about which unit is the largest out of the 3, and how do you know? Which unit is the smallest, and how do you know? When you're done, press play. So we are familiar with a 2-liter bottle and how much soda it holds, but how does that compare to milliliters? In the pictures, you can see the colored water being poured from a full 2-liter bottle into the graduated cylinder to see how many milliliters it is. As you can see, the bottle fills the graduated cylinder to the 2,000 milliliter mark. Therefore, 2 liters equals 2,000 milliliters. That also means that when it is reduced, 1 liter will equal 1,000 milliliters. You can fill that information in on questions 2 and 3. So if we think about this, if 1 liter equals 1,000 milliliters, what would this mean for grams and milligrams? Explain your answer to a neighbor. Write down your answer as well and explain your thinking on number 4. Now, think about the kilogram and gram drawing above. What do you think the relationship is between kilograms and grams? Explain your thinking to a neighbor and record your answer on number 5. When you're done, click play. So, summary of the metric system. Take a minute, pause the video, and fill in the table with all of the base units, symbols, and measurements, as well as the space below it, which has the base units and their prefixes. Then press play to get more information. Alright, so you should have all of the table filled out now. So let's talk about them. We have different base units that we use for measurements in the metric system. So just like the English system, which we use in the United States, where we would measure length with feet and miles and inches, the metric system has a measurement for length as well. We just call it meters. So instead of having different names for different sizes of length, we have one name. We call it all meters. So our different base units, we have grams, which measure mass, and mass is just the amount of space or the amount of substance that we have. So basically the amount of stuff contained in something, and its symbol is a lowercase g for gram. Our meters measure length or distance, and our symbol is m, lowercase m. Liters are a volume measurement, so how much space something takes up, and its symbol is a capital L. The Pascal is a pressure unit, and its symbol is capital P, lowercase a. And our last one is the joule. The joule is a measurement of energy, and its symbol is a capital J. So all of these measurements and base units allow us to measure all kinds of different objects and different qualities about them. Now, in the English system, like I was saying earlier, we have inches, and so many inches make a foot, and so many feet make a mile, and we have all these different names. In the metric system, instead of changing the name for every measurement, all we do is add a prefix to the word, to the base unit, to change its size. So for instance, a meter, we can add the prefix milli to say millimeter and say that it's a smaller version of a meter. We can also say kilometer or kilometer and say that it's a much larger version of a meter. So it's just basing it off of that same word and adding a prefix to the beginning. What we need to understand is what the prefixes mean and how we can change from one prefix to another. So down below the table, you have some more information. It says, for our first one, that 1,000 of any of our base unit equal 1 kilo of that base unit. So instead of saying base unit, we're going to put in one of these words. So if I say 1,000 meters equals 1 kilometer or kilometer, we can tell how they compare to each other. So if we took a meter stick, if we took 1,000 meter sticks, and lined them up end to end, that would equal the same distance as 1 kilometer. So like I said, instead of changing the whole word, we're just adding a prefix to the front. Similarly, if we had one of our base units, so if I had 1 meter, it would take 1,000 millimeters to make that meter. So if I took 1 meter stick and I could break it into 1,000 equal pieces, that distance would be equal to a millimeter. And we can keep breaking these down into smaller units. We can keep building them up into bigger units. So you've probably heard of other prefixes. For instance, another base unit we won't use in chemistry, but you might be familiar with in your life, is the byte. So we measure data on our phones and computers in bytes. You might have heard of megabytes. So mega is 1,000 times bigger than a kilo, so it's pretty big already. And then we have gigabytes, which are 1,000 times bigger than a megabyte. And then we have now, because we've gotten to a ridiculous place, we have terabytes. So we can store tons of data, a terabyte of data, and that's 1,000 times bigger than a gigabyte. And all it is adding a different prefix and changing how much we have. So it's still bytes, and bytes just measure data storage, and we can change how much we can store and by changing that prefix. The third line, which is on here, which is actually the to the right on your paper, says 1 milliliter equals 1 centimeter cubed. So let's talk about what that means. A milliliter is a pretty small volume, and it's measuring, or a liter is a measurement of volume. So volume, another way we can find it is by taking a cube. Draw a cube here. Oops, it's a little sad. And measuring the sides of it. So if I had 1 centimeter cubed, that means I have 1 centimeter on distance on each side. So 1 centimeter, times 1 centimeter times 1 centimeter equals 1 centimeter cubed. So that amount of volume that little cube takes up is the same amount of volume that a milliliter would take up. They're equal to one another. So anytime we see centimeters cubed, it is the same volume in milliliters. Our very last metric conversion that we're going to go over is temperature. So this last equation is a little bit different. It's for temperature conversion. Our two temperatures that we're going to use in this class are Kelvin and Celsius. So we say degrees Kelvin, or we say Kelvin and then degrees Celsius, excuse me. This equation shows you how they relate to each other. So if I have something in Celsius and I want to change it to Kelvin, you simply add 273. So the two scales are the same as each other, but they just have different starting points. So Kelvin starts at what we call absolute zero, or at 0 Kelvin, and Celsius starts at negative 273. So to change between them, we just have to add 273 to the degrees Celsius, and we can get our Kelvin temperature. We'll look at an example of that on one of the next slides. To the right on your paper, you have this picture, which you can add the arrows to. And it's just going to help you kind of see if we're going to be multiplying or dividing by that 1,000 to figure out our new unit. So if we go from our kilo down to our base unit, or our base unit down to milli, anytime we do that, we're going to end up multiplying by 1,000. And anytime we go the other direction, so we go from milli to base unit or base unit to kilo, we're going to end up dividing by our 1,000. So we multiply when we get smaller and we divide when we get bigger. So we can use that as a guide. All right, we're going to take a look at a couple of examples of metric conversions and how we set them up in chemistry. So we are looking at not only converting metric units, but also a method of how we want you to set up these conversions. So even if you've learned another method, we do want you to practice this way on your assignments so that you can learn this method. We will be using it again later this year, so it's a little easier to learn it now with metric than it is later in the year with the more complex information. So over here on the left, you can see that we have our general setup of our problems. So this is the approach we're going to take every time. We're going to always start by writing our given value, and then we draw this little T-chart. This T-chart helps us set up where everything goes. We also call it our railroad tracks in chemistry. On the bottom right-hand corner, we're going to end up putting the units that we do not want, and those units are the ones we're trying to get rid of. On the top, we're going to put the units we do want, so the unit we're trying to get to. And then we'll set up the numbers that we fill in into our table. Our first question says 500 milliliters equals blank liters. So our 500 milliliters is what we're given, so that is written first in the top left corner. What we want to find is liters. So what I always do first is take my unit of measurement that I want to get rid of, and I copy it to the opposite corner, milliliters. So that will allow us to get rid of that unit. And then the unit we want to go ahead and put on the top. If we set up our units first, it's going to help us know where to put the numbers, so we put them in the proper place. So now we need to know what the relationship is between milliliters and liters. Well, earlier when we were looking at the green liquid being poured into the graduated cylinder, we found out that 1,000 milliliters equals 1 liter. We also discussed in the previous slide, and it's written at the bottom of your page, that 1 of any base unit, like liters, is equal to 1,000 milli of that base unit. So we can say that 1 liter equals 1,000 milliliters. Now that we have that information, we can fill it in to our problem. So 1,000 milliliters equals 1 liter. Once we have that setup done, now we can take care of the calculations. Whenever we set up this chart, it doesn't have any math symbols in it, but we are going to multiply any numbers that are on the top, and we're going to divide by any numbers on the bottom. You can use a calculator for this, or you can do it in your head. So we have 500 milliliters times 1, then divided by 1,000. So 500 times 1 is 500, divided by 1,000 is 0.5. So we fill that in. The last part is to get our units. So when we take our milliliters that we start with and we divide by milliliters, the units cancel each other out. And we are left with just liters. So we record liters for our final answer. So 500 milliliters is equal to 0.5 liters. So it's half a liter, which makes sense. If 1,000 milliliters is 1 liter, half of that, 500 milliliters, is half a liter, or 0.5 liters. So this method gives us a way of setting up our problems to ensure that we're getting our units to cancel properly and making sure that we're doing our math correctly. Let's take a look at example 2. It says 25 cm. C represents centi. It's another one of our prefixes. So centimeters, because m is our base unit. 25 centimeters equals blank meters. So we're going to do the same type of setup. We start with our given 25 centimeters. We have our T, or our railroad tracks. The first thing we're going to do is fill in that same base unit on the bottom, or that same unit on the bottom. We want centimeters to go away. We're going to cancel them out so they go on the bottom. And we're going to put meters on the top because that is what we want. Then we need to figure out the relationship between centimeters and meters. Centi is not one of the prefixes that's on your page. So centimeters or centigrams or centiliters, we can use any base unit. If we have 100 of them, it equals 1 of that base unit. So if we have 100 centimeters, it equals 1 meter. That word centi might remind you of like cents, like we have dollars and cents. So 100 pennies makes up $1, just like 100 centi or cents makes up $1, or 1 meter. So now we can fill in our numbers in our problem. So 100 centimeters is 1 meter. And then we can do the rest of our calculation. Again, we're going to multiply on the top, and we're going to divide by the number on the bottom. So 25 times 1 is 25, divided by 100 is 0.25. And again, you're welcome to use a calculator on these problems if you need to. Now we just have to have our units. So centimeters is on the top and on the bottom. It will cancel, and we are left with meters. In both of these cases, we ended up dividing by our large number, the 1,000 or the 100. That will not always be the case. Sometimes we will multiply it, and it just depends on what unit we are given and what unit we are looking for. Our last part is a couple of temperature conversions. When we want to do a temperature conversion, it's going to be set up very simply, we're just going to plug the numbers into our equation. So our first example says 25 degrees Celsius equals blank Kelvin. So the way we use our equation, it says K for Kelvin equals, and it says degrees Celsius. So we have degrees Celsius, so we're going to plug that in, 32, plus 273. And actually, I'm going to leave off our degrees Celsius here. Erase that. So we have 32 plus 273. We add those two numbers together and we end up with, let's see, 3 and 2 is 5, 7 and 3 is 10, carry the 1, 305. So our Kelvin temperature is 305. So 32 degrees Celsius is probably about 85 degrees Fahrenheit, so a warm day in Fresno, and it's equal to 305 Kelvin. Our last example here is going the other way. If we're given Kelvin and want to go to Celsius, so we write 346 in place of the K equals degrees Celsius, because that's what we're looking for, plus 273. Now, we have to do a little bit more math here because we have to rearrange and get our degrees Celsius by itself. So to move the 273 over, since it's being added, we do the opposite. So minus 273 on each side. The right side cancels. 6 minus 3 is 3. 34 minus 27 is 7. So that is 73 degrees Celsius. So we can go either direction on our temperature scales. You can have negative numbers in Celsius, but you cannot have negative Kelvin. So that might be something you want to make a note of on your paper. And we always end with a joke. So metric system, that's too mainstream because we're the United States and we don't use the metric system. So that's way too cool for us. Or we're way too cool for it. I hope you have all your notes down. Have a great day.